During a school trip to Germany, each pupil was allowed to exchange £100 into euros for spending money. The exchange rate was 1.06 euros to the pound. How many euros did each pupil receive?
In this question, we are told that each pupil was allowed to exchange £100 into euros for spending money. And we are given this exchange rate here, that 1.06 euros is equivalent to £1. And the question asks us, how many euros did each pupil receive? Well, if they each have £100, and we know that £1 is equal to 1.06 euros, we just need to get this ratio to say £100 on the right hand side, and we can do that by multiplying both sides of this ratio by 100. And then we get that naturally £100 is equal to 100 times 1.06, which is 106. So the answer to this question is 106 euros.
90 pupils travelled to an exhibition on 2 coaches. Each coach cost £180 to hire. The total entrance fee to the exhibition for all pupils was £90. How much did each pupil have to pay to meet the total cost?
In this question we are told that 90 pupils travelled to an exhibition. Now we know there are 2 coaches, and each coach cost £180 to hire. And we know that the total entrance fee to the exhibition for all the pupils was £90. And the question asks us, how much did each pupil have to pay to meet the total cost? Well, the first thing we need to do is work out the total cost. So to start with, we have 2 coaches that cost £180 each. So the total cost for the coaches is going to be 180 multiplied by 2. Well, that's going to give us 360. So the cost for both coaches was £360, but now we need to include the entrance fee of £90, so we need to add 90 onto that. And if we do that, we get 450. So the total cost for the school trip was £450, but there were 90 people, so we need to work out the division here. So we need to do 450 divided by 90. Well, that's the same as 45 divided by 9, which is going to give us 5. So the answer to this question is £5.
A test is marked out of 60. Pupils need 75% to achieve grade A. How many marks is this?
So in this question we have that a test is marked out of 60, and pupils need 75% to achieve a grade A. And the question is asking us, how many marks is this? Well, there are a few ways of doing this. The way I would suggest is by noticing that 75% is exactly the same as 3/4. In other words, we just need to work out 3/4 of 60. Well, 1/4 of 60 is 60 divided by 4, which is 15. And then we multiply that by 3 to get 45. So 3/4 of 60 is 45. So the answer to this question is 45. The other way we could do this, which is going to take us slightly more time, is to say, well, 10% of 60 is 6, okay? And we've got 75%, so let's work out what 70% is. Well, that's going to be 6 times by 7, because 10% is 6, so 70% is going to be 7 times 6, and if we do that, we get 42. But that gives us 70%. We need to find out 5%. Well, if 10% is 6, 5% is 3. So we can just add on that 70% plus another 5%. That gives us 45 again.
The school library is open for 5 hours 20 minutes per day on Monday, Wednesday and Friday, and for 6 hours 30 minutes per day on Tuesday and Thursday. What is the total time the library is open during the school week?
In this question we are told that the school library is open for 5 hours 20 minutes on Monday, Wednesday and Friday, and 6 hours 30 minutes on Tuesday and Thursday. And the question asks us to find out the total number of hours that the school library is open for in the week. So all we actually need to do is notice that it's 5 hours 20 minutes on 3 days, and 6 hours 30 minutes on 2 days. So we need to do 5 hours 20 multiplied by 3. Well, the quickest way to do this is to deal with it in hours and minutes. So 5 hours times 3 gives us 15 hours. 20 minutes times 3 gives us 60 minutes, which is another 1 hour. Now 6 hours times 2 gives us 12 hours, and 30 minutes times 2 gives us another hour. So what we need to do is add these up. So we've got 15 plus the 12, which is going to give us 27, plus 1, 28, plus another one, 29. So the answer to this question is going to be 29 hours.
A primary school concert cost £80 for promotion, costumes and refreshments. The parents attending each paid £1.50 entrance fee. 60 parents attended. How much money was left for the school funds? Give your answer in pounds.
In this question we are told that there is a primary school concert and there's a cost of £80 to cover promotion, costumes and refreshments. We are told that the parents pay £1.50 as an entrance fee and 60 parents attended. And the question asks us how much money was left for the school funds. So what we need to do is to work out the difference between all the costs and the revenue. In other words, let's work out how much the parents paid in total for the entrance fee. Well, if 60 parents each paid £1.50, then the calculation we need to do is 60 multiplied by 1.5. Now we are more than welcome to do this in a grid, but if you're multiplying a number by 1.5, you are increasing it by 50%, or you're increasing it by a half. And a half of 60 is 30, so 60 plus the extra 30 gives us 90. So this is going to give us 90. So in total there was £90 generated from the entrance fees, but we need to take away from that the £80 for promotion, costumes and refreshments. And when we do that, we are left with £10. So that is the amount that was left for the school funds.
A school sold copies of the class photograph to 28 pupils in the class for £2.50 each. What was the total amount raised from the sales of the photograph?
In this question we are told that a school sold copies of the class photograph to 28 pupils in the class for £2.50 each. And we need to find the total amount raised from the sales of the photograph. Well, if 28 pupils each spent £2.50 on the photograph, then in total they spent 28 multiplied by £2.50, or 2.5. Now there are a few ways of doing this. You can do this in a grid. You can notice that multiplying a number by 2.5 is the same as multiplying it by 2 and then adding on half the number. Or you could notice, this is the trick, where you have 25 multiplied by a multiple of 4. Now I know this isn't 25, but it's 2.5, so we've just divided that by 10. So 28 I can write as 7 times 4. But 4 times 2.5 is 10. It's £10. So what we actually have is 28 times 2.5 is the same as 7 times 4 times 2.5, but we know 4 times 2.5 is 10. So it's just the same as 7 times by 10, which is £70.
What is 15% as a decimal?
In this question we are asked to write down what 15% is as a decimal. Now this is a very, very easy question, and the answer is just going to be 0.15. We would expect that you would be able to know that off the top of your head. So for example, if it was 20%, it's 0.2, 30%, 0.3, 75%, 0.75. We expect you to be able to do these sorts of conversions. But we can have a look at this in a little more detail. Percentages are always out of 100, so 15% is the same as 15 out of 100. But 15 out of 100 is the same as 15 divided by 100, because this is what the fraction sign actually means. It just means divide. And 15 divided by 100 is 0.15. So the answer is just 0.15.
In a year group of 45 pupils, 27 were boys. What fraction of the year group was girls? Give your answer in its lowest terms.
So in this question we are told that there are 45 pupils, of which 27 are boys, and we need to find the fraction of girls. Well, if 27 are boys, then 45 minus 27, which will give us 18, are girls. So the fraction is going to be 18 out of 45. But we need to give this fraction in its lowest terms, so we're going to have to reduce it. Well, both the top and bottom are not even, but we know that 45 is 9 times 5. So 18 is not a multiple of 5, but it is a multiple of 9. It's two lots of 9, so we can divide both sides by 9, and we're going to get 2 out of 5. And that's it reduced in its final form. So the answer to this question is 2/5. Of course, the other way we could do this question is to say, well, the fraction of boys is 27 out of 45. We can divide by 9 to get 3/5. So if 3/5 are boys, then 2/5 are girls. That would be the other way of doing this question.
A teacher plans a cross-country competition. The course is 3.45 kilometres long. Pupils do 3 laps of the course. What is the total distance run by each pupil in kilometres?
Okay, so in this question we are told the cross-country course is 3.45 kilometres long and each pupil does 3 laps of the course. And the question asks us, how far does each pupil run in total? Well, we just need to do 3 multiplied by 3.45. So let's do that. So we've got 3.45 and we're going to multiply that by 3. Well, 5 3s are 15, so we've got 15 here. 4 3s are going to give us 12. And then we need to do 3 3s, which are 9. And then we need to add all these up and just be careful that we keep everything in the same column. So we've got 5 here, a 2 plus 1 is a 3, and a 9 plus 1 is 10. So the answer to this is 10.35, and that's kilometres.
There are 35 schools in a local authority. 28 schools have been inspected in the last 4 years. What percentage have not been inspected?
Here we are given that there are 35 schools in a local authority and 28 have been inspected in the last 4 years, and the question asks for the percentage of schools that have not been inspected in the past 4 years. Well, if 28 have been inspected, that means that 35 minus 28, which is going to give us 7, have not been inspected. Well, that's 7 out of 35, so we could do 7 divided by 35 here in short division, but I would have a look at reducing this fraction first. Notice that 7 and 35 are both multiples of 7, so we can divide the top and the bottom by 7 to get 1 over 5. So the fraction is 1/5. Well, 1 divided by 5 is 0.2. This is a fraction we recommend you learn the conversion off by heart, but if not, it's quite easy to do 1 divided by 5, because to divide by 5, the quick way is to multiply by 2 and divide by 10. So 1 multiplied by 2 is 2, divided by 10 is 0.2. And 0.2 as a percentage is therefore 20%. So this is the answer.
A school play begins at 1900 hours. It has one interval of 15 minutes. The play is 1 hour and 55 minutes long. At what time does the play end? Give your answer using the 24-hour clock.
So in this question we are told that a play starts at 1900, it lasts for 1 hour and 55 minutes, and there's a 15-minute interval in between. And we are asked to find the time that the play finishes, and to give our answer in the 24-hour clock. So what I would first do is work out the total duration. So we need to add 1 hour 55, so I'm going to use the colon notation to separate hours and minutes, that's 1 hour 55 minutes, and then we're going to add to that 15 minutes, so that's going to be 0:15. And let's do that. So we get 5 plus 5 is 10, so we write a 0, we carry 1. 5 plus 1 is 6, plus this 1 we carried over gives us 7, and 1 plus 0 is 1. So we have 1 hour 70 minutes. But 70 minutes is bigger than an hour. It's 60 plus 10. So this is the same as 2 hours and 10 minutes, okay? Because 1 hour 70 minutes is the same as 2 hours 10 minutes. So we just need to add 2 hours and 10 minutes onto 1900. And when we do that, we get 0 plus 0 is 0, 0 plus 1 is 1. 2 plus 9 gives us 11, so we have 1 here, and then carry a 1, and then 1 plus this 1 gives us 2. So the answer to the question is 21:10.
0.9 of a year group of 180 pupils took part in the school sports day. How many pupils did not take part?
So in this question we are told that 0.9 of a year group of 180 pupils took part in the school sports day, and we are asked to find the amount of pupils that did not take part. Well, 0.9 of a year group is the same as 90% of the year group, or 9/10. It's just a proportion, okay? So the long way to do this is to say, well, it's 90% of the year group, so we need to do 180 multiplied by 0.9. Or we could just say, well, if 10% is 18, then 90% is 9 times 18. But that's unnecessary, really, because we are asked to find the number of pupils that do not take part. So if 0.9 of a year group do take part, that means that 0.1 of the year group do not take part. But 0.1 of the year group is 10% of the year group, and 10% of 180 is 18. So the answer to this question is 18 pupils. This question asks us, approximately, what fraction of the pupils attended the sports club? Now we can see that we are given a table here that gives us the attendance at after-school clubs. Now we can see that from the table 18 pupils attended sports clubs, and that was out of a total of 53. So naturally the proportion is going to be 18 out of 53. But we're given fractions here, so the best thing to do here is to calculate this proportion as a decimal and then compare these fractions as decimals to see which are the closest. So if we type 18 divided by 53 on our calculator, we get 0.3396 ... Okay? So we need to go through each of these fractions and see which one is the closest. Well, let's start with a quarter. Well, a quarter we know is 0.25. Now a third is 0.33333, that goes on forever. Again, we can just type 1 divided by 3 on our calculator if we didn't know that. Now 2/5 is going to be 0.4. Again, we can type 2 divided by 5 on our calculator to get that. And 3/8 we can do is 3 divided by 8, which is 0.375. So we can see that the closest one of these to 0.3396 is a third at 0.333. So the answer to this question is 1/3. So in this question we are told that a survey of pupils shows that at least 30% of all the 256 pupils in a school want to come to after-school clubs. And the question asks us, what is the minimum number of extra pupils above the 53 who want to come to after-school clubs? Well, the first thing we need to do is work out how many people do want to come to after-school clubs. Well, we're given here that at least 30% of all the 256 pupils in the school want to come to after-school clubs. So let's work out what 30% of 256 is. Well, we can do that by typing 0.3 multiplied by 256 on our calculator, and that gives us 76.8 pupils. So at least 76.8 pupils want to come to after-school clubs. So that means at least 77 pupils want to come to after-school clubs. We can't have 0.8 of a student. So at least 77 pupils want to come to the clubs, but we know that 53 attended. So we need to do 77 minus 53, which gives us 24. So the answer to this question is 24. So in this question, we are given this table that shows the percentage of candidates achieving each grade in their GCSE mathematics from 2007 to 2010. Now the percentages are rounded to the nearest whole number, and we are asked to indicate all the true statements. So let's have a look at the first statement. This claims that the number of pupils who gained a U grade increased each year. So we need to look at this column here, as this represents the U grade. Now be very careful. Notice how the table says percentage of candidates achieving each grade. These are not numbers, so we cannot simply just read to see whether this number gets higher or not. So what this means is that in 2007, 6% of the 180 pupils got a grade U. So we need to do 0.06 multiplied by 180 to find 6% of 180, and that gives us 10.8. And now we do the same for 2008. We have 5% of 200, so we do 0.05 multiplied by 200, that gives us 10. So we can see that the number of people who gained a U decreased, because between 2007 and 2008 it decreased. So this means that statement A is false. Let's have a look at the second statement. So the number of pupils who gained a grade C increased each year. Well, we're going to have a look at this column here for the grade C, and this column here for the total number of pupils. So in 2007, 23% got a grade C, so we need to do 0.23 multiplied by 180, and that gives us 41.4. In 2008, we're going to do 0.22 multiplied by 200, which gives us 44, so it has increased. In 2009, we're going to do 0.22 multiplied by 230, which gives us 50.6. Again, it's an increase. And finally, in 2010, we're going to do 0.2 multiplied by 270, and that gives us 54. We can see that the number of pupils who gained a grade C did in fact increase each year, so this means that this statement here is true. Finally, the last statement claims that the number of pupils who achieved a grade B in 2010 was double the number with the same grade in 2007. Well, let's have a look. We need to have a look at the column here for grade B. And again, we're going to look at the total number of pupils. So in 2007, we had that 15% of the 180 pupils got a grade B. And 0.15 multiplied by 180 gives us 27. So we know there were 27 people who got a grade B in 2007. Let's do the same for 2010. We can see here that 20% got a grade B in 2010. So we do 0.2 multiplied by 270, which gives us 54. And of course, 54 is double 27. So this statement is also true. In this question we are told that as part of a review of performance, a geography teacher prepared a table of marks for 8 pupils from a series of tests throughout the year. And the question asks us to drag and drop the correct values to complete the table. So we can see we've got this first box here, and this, we can see from the column, relates to the mean for the pupil. Okay? So what we need to do is to find the mean. Well, we can do that by adding up all their test marks and dividing by the number of tests. Well, there are 5 tests. So we're going to do 41 plus 51 plus 44 plus 56 plus 67. And if we do that, we get 259. But then we need to divide that answer by 5, which gives us 51.8. So what we need to do is drag this box here into that over there. Okay, now we're going to have a look at this remaining box here. Well, be careful. This relates to the range, not the mean. Okay? So what we need to do is to work out the range of test 5. Well, that's the difference between the highest and the lowest mark. So having a look at the list, we can see that the highest mark here was 70, and the lowest mark was 27. So the range is going to be 70 minus 27, which is going to give us 43. So finally we need to drag this box into this box here. So in this question we are told that a newly qualified teacher attends a series of training courses during the induction year. Now we are told that the teacher can claim travelling expenses of 32.5 pence for the first 100 miles and 27.5 pence per mile for anything above 100 miles, in addition to any train fares. We are also given that the teacher travels by train on the 17th of December and the 11th of April at a cost of £11.50 and £4.70 respectively, and we can see that indicated on the table here. So what we need to do is to work out the total mileage, so we need to add up all these distances here, okay? So we're going to do 27 plus 27 plus 32 plus 32 plus 32 plus 18 plus 18, and if we do all that, we get 186 miles. So that's 100 plus 86, because remember the first 100 miles she can claim more for. So that's 100 miles where she can pay the full 32.5 pence per mile. So if we do 100 times 32.5, that gives us 3,250 pence. We would only then divide that by 100 anyway to get £32.50. So she can claim £32.50 for the first 100 miles. And now for the remaining 86 miles, well, we need to do 86 multiplied by 27.5, which gives us 2,365 pence. But we need to divide that by 100 to get our answer in pounds. So that gives us £23.65. So now all we need to do is add these two costs together and then add the 2 train fares as well. So we're going to do 32.5 plus 23.65 plus 11.5 for the first train and 4.7 for the next one. And if we do all that, we get £72.35. Okay, so in this question we are given this box and whisker diagram here, and we are asked to indicate all the true statements. Now the first statement claims that Class A boys have the greatest range of percentage marks. Well, remember, the range is the difference between the highest and the lowest mark. So the range for Class A boys is indicated by that distance there. Now we could put numbers to this and work out the range for each of these 4 plots and see which is the biggest, but you can do this visually. If you just look at the distance there, how big it is compared to this one, and this one, we can see visually the range for Class A boys is much higher than all the others. So this first statement is true. Now the second statement claims that Class A girls have the lowest median and the smallest range of percentage marks. So let's have a look for Class A girls. Well, Class A girls is here, and the median is indicated by this white bar here. So we can see that the median is clearly lower than any of the others. And now let's have a look at the smallest range. Well, this one's quite tight. It's going to be between this one and this one. But again, you don't need to put numbers to this, because notice how they look to have the same highest mark, but the lowest mark for the Class B girls is lower. So we know, or again by inspection, that this statement is true. Finally, the last statement claims that only Class B boys have a median percentage mark above 50%. Well, let's have a look. We can see that the 50% mark is here, and if we draw all the way across, we can see that that is false. So there's the Class A boys that had a median above 50, and the Class B boys also had a median above 50. So this statement is false. In this question we are told that for a school visit to Iceland, each of the 25 pupils is allowed to take £40 spending money. Now we are given that the exchange rate is £1 to 141.5 krona, and commission of 1% was charged. And the question asks us, how many krona did each pupil have as spending money after the commission was deducted? Well, we can see here that they are allowed to take £40 spending money, and we are given this exchange rate here, that £1 is equivalent to 141.5 krona. Well, that means that £40 is equal to 40 times by 141.5 krona. And if we do that, we're going to get 5,660 krona. But we can see here that commission of 1% was charged. So this means that 1% was taken away from that total. So you could work out what 1% is and deduct that from 5,660. But the quicker way of doing that would be to realise that if they take 1% away, you've got 99% left. So we need to work out what 99% of 5,660 is. And we can do that by typing that on our calculator. So we're going to do 5,660 multiplied by 0.99. And that gives us 5,603.4 krona, and that is the answer. In this question we are given a diagram that shows the percentage of pupils achieving a level 4 and above. Now the blue line on the graph represents the national results, and the pink line represents the school's results. And we are asked to indicate all the true statements. Now the first statement claims that the school's results were better than the national results in 3 of the 5 years. So what we need to do is go through each point individually and to count the ones in which the school's results is higher than the national. Well, let's have a look. In year 2, the blue line is higher than the pink line. In year 3, the pink line is higher than the blue line, so that's 1 year. In year 4, again the blue line's higher. In year 5, the pink line's higher. And in year 6, the pink line's higher. So we can see that the school's results were better than the national results in 3 out of the 5 years. This means that statement 1 is true. The second statement claims that the school's results were within 2% of the national results each year. Well, let's have a look at year 2. So the national results were 62 and the school's were 60. That's a difference of 2. As we move to year 3, the school's results were 62 and the national results were 59. That is a difference of 3. So this means that this statement is false. Finally, the last statement claims that the improvement for the school from Year 2 to Year 6 was 3 percentage points better than the national improvement from Year 2 to Year 6. Well, if we have a look at the school in Year 2, we can see that the results were 60, and this rose to 72 in Year 6. That's an improvement of 72 minus 60, which is 12. Now let's have a look at the national results. So in Year 2, we started at 62%, and this rose to 71% in Year 6. Therefore, the improvement is going to be 71 minus 62. It's a difference of 9. So the school had an overall improvement of 12, the national had an overall improvement of 9. So the school's improvement was 3 percentage points higher than the national's improvement. So this statement is also true. So in this question we are asked to click on the class in the table which has half of all the pupils in the year group who speak exactly 2 languages. Okay, so we can see from this chart here that the number of languages spoken to, there's a total of 15, 16, 17, 18 people. Okay, so there's 18 people in the year group who speak 2 languages, and we need to click on the class in which half of the 18 people, 9 people, speak 2 languages. So essentially what we're looking for is the class which represents half of this column here. And we can see from inspection it's clearly going to be this yellow one here, class W. But what we could do is read off the graph to make sure this is correct. So we can read off here that this has a height of 9. So class W has 9 pupils that speak 2 languages. So it has half of the pupils who speak 2 languages. Therefore the answer to this question is going to be class W. In this question we are told that a school in Manchester is planning to visit a school in Exeter, and some of the journey will be on motorways and the rest of the journey will be on ordinary roads. And we've got this table here that shows the planned journey details. Now we are also given this formula that is used to estimate the total journey time, and the question asks us, if the average speed is 60 miles per hour, what is the journey time according to the formula? So what we need for the formula is we need the total distance in miles and the average speed. Now we're given the average speed, that is 60, so we need to find the total distance in miles. Now we have to be quite careful here. So notice that this is a cumulative frequency table. So what this means is by the time you've arrived at school, you've travelled a total of 240 miles. So what you don't want to do in this question is add up all of these values, okay? Instead, we just need to look at the final value. So the total distance was 240 miles. Now what we need to do is just simply put this into the formula. So we have that the time is equal to the total distance in miles, 240, multiplied by 1.25 divided by 60. Now 240 multiplied by 1.25 gives us 300. So we have 300 divided by 60, which gives us 5. So the answer to this question is 5 hours. In this question here, we are given a scatter graph that compares the number of computers against the number of pupils. Now we are told that for the school, the mean number of pupils is 217 and the mean number of computers is 33. And we are asked to click on the dot that represents the school that is closest to the average. Well, we are told that the mean number of pupils is 217. Now the increments here are going up in 5, so we've got 175 goes to 180, 185, 190, 195, 200. So we need to look for 217. Well, we've got 200, so 205, 210, 215, so it's around about here, okay? But we also need to take into consideration the mean number of computers, which is 33. Now the increments here on the vertical axis are 2, because we've got 20 to 22, 24, 26, 28, 30. So we want to look for 33, well it's going to be 30, 32, 33, it's going to be halfway here, okay? And now we just need to click the dot that is closest to the intersection of these two lines. And we can see that the dot that is closest to the intersection is this one here. So that is the answer. So in this question we are told that a parent's evening is planned to last from 1615 to 1900. Within that time, teachers will have a break from 1730 until 1745. We are told that each appointment is scheduled to last 8 minutes. And the question asks us what is the maximum number of appointments each teacher can have. Now we have to be a little careful here because we can't consider the total time between 1615 and 1900 because the break is fixed. No matter what, the teachers will have a break from 1730 to 1745. So what we want to do here is to actually split this up into two halves, if you like. So we've got the first half of the Parents' Evening, which commences at 1615 and finishes at 1730 when they go on their break. And then the second half of the Parents' Evening, which begins at 1745, the end of their break, and ends at 1900 when the Parents' Evening officially ends. Now both of these are 1 hour and 15 minutes in duration, okay? So we can just work out how many appointments are in one of those halves and double it, okay? Well, 1 hour and 15 minutes is the same as 60 plus 15, which is 75 minutes. So we need to know how many 8-minute slots we can fit into 75. So on our calculator we are going to do 75 divided by 8. We're going to divide it into 8 different pieces. And we get 9.375. So this means that in each of these slots we can get 9.375 appointments. But of course, 0.375 of an appointment doesn't really make much sense. We are going to have to round down. If we can get 9.375 appointments in, we cannot get 10 appointments, so we can only get 9 in each half. So the answer to this question is going to be 9 multiplied by 2, which of course is 18. In this question we are given a bar chart that shows the staff days out of school for professional development from 2003 to 2008. Now we are also given a table here that shows the total number of staff days out for school for all reasons from 2003 to 2008. And the question states, drag and drop the correct values into the boxes to show the proportion of staff days out for school for professional development in 2005 and 2008. Well, in order to answer this, we have to be very clear about what graph is showing. Well, we are told that the bar chart shows staff days out strictly for professional development, whereas the table shows the total number of staff days out of school for all reasons. So we need to know the proportion of staff days out of school for professional development. So what we need to do is we need to find the number of staff days out for professional development and divide by the total number of days out for all reasons. So let's have a look in 2005, shall we? So we can see from the bar chart over here that in 2005 there were 26 staff days for professional development. But that was out of a total of 40. So the proportion is going to be 26 out of 40. And if we put 26 divided by 40 into our calculator, we get 0.65. So what we need to do here is we need to drag 0.65 into the box representing 2005. Now let's have a look at 2008, where we can see from the bar chart that there were 24 staff days for professional development out of a total of 60. So the proportion is going to be 24 out of 60, and if we put 24 divided by 60 in our calculator, we get 0.4. So what we need to do is to drag the 0.4 box into the 2008 box here. In this question we are given a chart that shows the Key Stage 2 average points for all core subjects. The yellow line represents the national score and the blue line represents the school score. Now the first statement claims that the school's lowest point score was in Year 4, so what we need to do is look for the lowest point on the blue line, and we can see that that was indeed in Year 4 here with 22. So this means that the first statement is true. Now let's have a look at the second statement. This claims that the school's average point score fell from Year 2 to Year 4. Well, again, we're looking at the school, so we need to look at the blue line. So from Year 2 we were at 25, and at Year 4 it dropped to 22. So again, this did fall, and this statement therefore is true. Now let's have a look at the third statement. It claims that since Year 4, the trend of improvement in the school's average point score has been greater than the trend of improvement in the national point score. Well, let's have a look at the school first. So in Year 4, we were at 22, and this rose all the way to 27. So that is a difference of 5. So that's an improvement of 5. On the other hand, the national seemed to be at the very low end here, so 27.2, something like that. And by the end of Year 8, they look to be about 27.8. You can see the climb is nowhere near as great as the school, so this means that statement 3 is also true. In this question we are given the same graph from the previous question, but now we are asked to select the year in which the school made the greatest progress in average point score. Well, if we look at years 2, 3 and 4, we can see between year 2 and year 3 and year 3 and year 4, there's a decrease. So we can just forget that. Now, between year 4 and year 5, there's a slight climb there. Similarly, with year 5 and year 6, there's a slight climb. But let's look at year 6 and year 7. There's a massive gain here. So it's roughly around about 23 in year 6. And this rises all the way up to about 25.8 in year 7. So that's a big jump. And look how steep the line is there. The other contender is between year 7 and year 8, where we're about 25.8 and we rise all the way up to 27. But as we can see, the line is steepest between year 6 and year 7. So the year in which the school made the greatest progress was definitely year 7. In this question we are given that a teacher compiles a test with a total of 60 marks, and he wants to compare the performance of this test with that of a previous test that had a total of 75 marks. Now, to convert the marks out of 60 to the marks out of 70, he should multiply by what? So the question is asking us to find the multiplier we would need to multiply a mark out of 60 by to get the equivalent to a mark out of 75. Well, all we actually need to do here is to find out how many times bigger 75 is than 60, and then we will multiply 60 by that number, okay? So if we want to find the increase between 60 and 75, well, we just want to find out how much bigger 75 is than 60. So we could go 75 divided by 60 in our calculator. And if we do that, we get 1.25. This means that 75 is 1.25 times bigger than 60. So what we need to do is multiply our mark out of 60 by 1.25, and we will get the equivalent mark if it were out of 75. So the answer to this question is 1.25.